McLaren lost both cars before the race even started, and Mercedes' explanation only raises more questions. Lando Norris never even made it to the start. Oscar Piastri lost his car on the grid. Andrea Stella confirmed that these were two different failures, but both within the same system. Toto Wolff described it as unfortunate. But in an F1 engineering context, two separate failures in one critical area at the same time is not something you can easily dismiss with a simple narrative. All early indications point to the electrical side of the Mercedes power unit, the most complex and least proven part of the 2026 regulations. This isn't a component you expect to be fully stable from the outset. What stands out is the distribution of performance and reliability between Mercedes and its customer teams. The data suggests there is a gap, not just in performance, but in how consistently the system operates. If Mercedes fully understands this power unit, why is the works team relatively unaffected while a team like McLaren suffers a complete failure? What happened in China needs to be separated into two layers: what we know and what we are being told. On the surface, the explanation is straightforward. Norris suffered an electrical issue that prevented the car from even leaving the garage. On the other side, Piastri's car made it to the grid, only to shut down before the formation lap and refuse to restart. Two failures, two different moments, but both terminal. Andrea Stella was clear in his wording. He stated that these were not the same failure. From an engineering standpoint, that distinction matters. It tells us that this is not a single defective part failing twice. Instead, it suggests that two separate failure modes were triggered within the same system architecture. That system, crucially, is the electrical side of the power unit. And in 2026, that is where the complexity lies. The new regulations have shifted a significant portion of performance reliance onto electrical systems. With roughly half of the total power output coming from hybrid deployment, the margin for error in energy management, battery stability, and system integration is dramatically reduced. This is not simply a more powerful version of previous hybrid systems. It is a fundamentally more demanding one. Which brings us to Mercedes, because while McLaren is the team that suffered the consequence, the hardware originates from Mercedes' high-performance powertrains. And while no one is publicly assigning blame, the pattern of failure forces the question into the open. Toto Wolff described the situation as an unfortunate coincidence. That is a reasonable position from a leadership standpoint. It avoids premature conclusions and protects the working relationship between supplier and customer. But it doesn't fully address the technical anomaly.